Good day everyone, welcome back to Together into Infinity's YouTube channel. For today's video, we are going to discuss the applications of definite integrals. But first, we need to know the meaning of the lesson so that it will be easy for us to solve the problems. So let's get started.
Definite integrals are integrals which have upper and lower limits. They are also defined as the limit in summation in order to find the net area between a function and the x-axis. These integrals represent the area under the curve of a function. Definite integrals can also be used to measure the velocity of an object, as well as to evaluate the volume and areas of complicated regions. Now that we know the definition, let us now solve some examples involving the application of definite integral.
In example number 1, we have y is equals to x squared, y is equals to square root of x is equals to 1 over 4, x is equals to 1. Fixing the values, we can have it as integral of f of x minus g of x with the limit of x sub 0 to x sub 1 or the sum rule. Substituting the values, it will be integral of x squared minus square root of x times dx with the limit of 1 over 4 to 1. In here, we can apply the fractional exponent rule on square root of x, so it will be x raised to 1 over 2. Next is to separate both functions, integral of x squared dx minus integral of x raised to 1 over 4 dx. Applying the antiderivative, we will get x cubed over 3 minus x raised to 3 over 2 over 3 over 2. Getting the reciprocal of the denominator 3 over 2, we will get x cubed minus 2x raised to 3 over 2 over 3. Substituting the boundaries, 1 and 1 over 4, 1 raised to 3 minus 2 times 1 raised to 3 over 2 over 3 minus 1 over 4 raised to 3 minus 2 times 1 over 4 raised to 3 over 2 over 3. Calculating the values, our final answer will be 49 over 192 square units or 0.26 when converted into decimal form. Remember that this example involves a vertical strip of a parabola. That is why the graph of y is equals to x squared, y is equals to square root of x is equals to 1 over 4, x is equals to 1 will look like this.
In example number 2, we have to find the area between the curves of y is equal to x cubed minus 4x and y is equal to 0 on interval 0, 2. First, we have to identify the given values such as function of f of x is equal to y cubed minus 4x, function of g of x is equal to 0, and an interval of 0, 2. For this example, we're going to use the formula integral of f of x minus g of x between a and b dx. Then you have to substitute the given values in the formula, which will result to integral of y cubed minus 4x minus 0 between 0 and 2 dx. Take note that putting 0 right from the start until the end of your solution won't be necessary, so it will be better if we remove it. Once you're done in substituting the given values in the needed formula, we have to find the antiderivatives of both f of x and g of x, and applying the sum rule will do so. Applying the sum rule will give us an expression of integral of x cubed dx minus integral of 4x dx. Finding its derivative will give us an expression of x to the 4th power over 4 minus 2x squared between the boundaries of 0 to 2. For us to finally arrive at our final answer, we have to use the formula of fundamental theorem of calculus or FTOC, which is the f of b minus f of a between the boundaries of a to b. Then substitute the values and boundaries needed in the formula, and it will become quantity of 2 raised to 4 over 4 minus 2 multiplied by 2 squared minus the quantity of 0 raised to 4 over 4 minus 2 multiplied by 0 squared. Use your scientific calculator for you to get a final answer of 4 units squared. Remember that this example involves a vertical strip of a parabola. That is why the graph of y is equal to x cubed minus 4x and y is equal to 0 on interval 0, 2 will look like this.
On our third example, we have y is equal to cosine 2x, y is equal to 0, x is equal to pi over 4, and x is equal to pi over 2. So the first thing to remember here is that this example involves a vertical strip of a parabola. So by fixing the values, we can have it as the integral of the absolute value of f of x minus g of x times dx between x sub 0 to x sub 1. So by substituting the values, we will have the integral of the absolute value of cosine 2x minus 0 times dx between pi over 4 to pi over 2. By eliminating the absolutes, it will be considered as the integral of cosine 2x minus 0 between pi over 4 to pi over 2. So take the constant out using the integral of a times f of x dx equals the integral of a times f of x. Then it will be considered as the integral of cosine of 2x dx between pi over 4 to pi over 2. We will not include 0 anymore since it won't be necessary for the solution, meaning to say that it won't really change anything Next, applying the u substitution. We have u as 2x, so our du will be 12. So it will be considered as the integral of cosine of u of dx between 1/2. So by getting the common integral of cosine, we will get 1/2 times sin of u. So by bringing back the value of our u, it will be 1/2 times sin of 2x. By evaluating the integral, it will be considered as sin 2x divided by 2 to the integral between pi over 4 to pi over 2. So by substituting the boundaries of the x variable, we can now have it as sin 2 times pi over 2 all over 2 minus sin 2 times pi over 4 all over 2. So by calculating the values, our final answer will be 1/2 square units or 0.5 in decimal form. So remember that this example involves a vertical strip of a parabola. That is why the graph of y equals cosine 2x, y equals 0, x equals pi over 4, x equals pi over 2 will now look like this picture shown.
For our real-life problems involving the applications of definite integral, here is an example. A certain dining room can be described by the region bounded by the y-axis, x-axis, and the lines y equals 25 minus 5x and y equals 1 over 2x plus 3. The dining room has to be tiled by the linoleum, which costs 100,000 pesos per meter squared. Find the cost of the linoleum needed to cover the dining room area. So the first thing that we need to do is to know that the line from the points 0 to 3 to 4 to 5 is given by y is equals to 1 over 2x plus 3. And the line from points 4 to 5 and 5 to 0 is given by y is equals to 25 minus 5x. So to find the total area of the dining room, we have to use the formula a sub 1 plus a sub 2. So knowing that a sub 1 is equals to 1 over 2x plus 3 and a sub 2 is 25 minus 5x, we can therefore substitute these values in the given formula and can be expressed as areas is equals to the integral of 1 over 2x plus 3 between 0 to 4 dx plus the integral of 25 minus 5x between 4 to 5 dx.
Next thing to do is to get its antiderivatives, which will give us an expression of quantity of 1/4 x squared plus 3x between the boundaries of 0 to 4 plus the quantity of 25x minus 5 over 2x squared between the boundaries of 4 to 5. Once you're done in getting its antiderivatives, we are now going to solve a sub 1 and a sub 2 separately using the fundamental theorem of calculus or the FTOZ's formula. In a sub 1, we get a total area of 16m squared, whereas in a sub 2, we get a total area of 2.5m squared. And adding these two areas will give us an answer of 18.5m squared. So the total area of the dining room that needs to be covered with linoleum is 18.5m squared, shown in the graph. Since we are finding for the total cost of linoleum needed to cover the dining room, we need to apply the formula cost of linoleum, which is 100 per m squared multiplied by the area, which is 18.5m squared. Then substitute the needed values and it will give us a final of 1,850 pesos. So we can therefore conclude that the total amount needed to cover the dining room with linoleum is 1,850 pesos.
And that is all for now. We hope that you learned something from watching our math tutorial about the substitution rule of definite integrals. See you in our next video. Bye!